Today we're going to talk about concepts that are important when we study organic reaction mechanisms. So we're going to talk about, say, essential elementary steps, and then about nucleophiles and electrophiles. So first I want to say that in most organic reactions happen in some sort of, say, are polar in nature, let's say. And what I mean by that is that we have charges of some sort. We may have positive charges or negative charges, formal charges, or just partial charges. And that is, for most reactions, we have exceptions, of course, radical reactions and pericyclic reaction, but we're going to be looking into those. And for this reaction, we have, some steps that repeat and then combine in different ways when we have mechanisms. One, we're going to call nucleophilic attack. Now we're going to talk about what is a nucleophile. Two, we have proton transfer reactions. And I'm going to give you an example of that. We have another type of step here, which is the loss of leaving group. And those are crucial. Again, they repeat and combine in different ways when we do a reaction. Lastly, say rearrangement. And in particularly, we in Organic Chemistry 1, we study carbocation rearrangement. So let's talk first, what is a nucleophile? And because common mistakes come from not identifying what is a nucleophile and what is a base, and identifying this first two. So I'm going to give you an example. Say that I have for this reaction. We have seen proton transfer reactions a lot when we study acid-base reactions. Say that I have this base, and I'm just going to put a formal negative, make things a bit easier. And now say I have a bond here in the base. Remember how we draw arrows. Arrows need to show the flow of electrons. So from the electron source here, they're going to get a proton. And now this reaction, this is the acid, that's the base, and we're going to get the conjugate base and the conjugate acid. Now in this reaction, we have seen that a proton that was attached here to A is now a B. So that's an example of a proton transfer. And I want to point out that we have here one species, this species B, is electron rich. And that's precisely what is in common with nucleophiles. So nucleophiles are also electron-rich species. So I'm going to erase this at the bottom because what I want to do is make the point that what is the same in nucleophiles and bases and what's different. Okay, so now let's think of, let me give you an example of, let's do, here I have acetone, and say that I have hydronium ion, right? So some sort of acid. Now, in this reaction, we're going to see electrons coming from this species, which is acting as a base. And we know it's acting as a base, as a Bronsted-Lowry base, because it's acting here is getting a proton. Remember that protons in the are transferred in acid, Bronsted acid-base reaction, and we define Bronsted bases as proton acceptors and proton donors at Bronsted-Lowry acids. So that's your base, that's your acid, and that is a proton transfer reaction. And you have the conjugate acid here is protonated acetone, and water is your conjugate base. Now that's a typical example of a proton transfer reaction. So let's see now what would be a nucleophile, an example of a nucleophilic attack. Now in the case of nucleophilic attack, the electron-rich species here, instead of acting extracting a proton, it's going to attack on something else. In particularly in organic reactions, we're going to see that a lot attacking carbon centers. So let's do an example of a nucleophilic attack. Here we have, I'm going to draw acetyl chloride and say that I have here water. Now, we have different electron-rich species, and we say that electron-rich species, such as this one here with negative charge, can act as a base, and is doing that, extracting a proton. But also electron-rich can act as nucleophiles. So they can be bases, or they can be nucleophiles. And again, they act as bases if they attack here on a proton. If they attack on something else, it is acting as a nucleophile. So in my example here, we see electron-rich species can have lone pair, or they can have a negative charge, for example. They can even have high electrons, can act as nucleophiles. So a variety of species that are electron-rich can be used as bases or nucleophile. So in this example, this is my electron-rich species, but now notice that it's attacking on a carbon. So this is an example of a nucleophilic attack. Now, because you have a carbon here with 4 bonds and you don't want to expand the octet, you need to do a second arrow. So products here are going to be, now I have added water, right? And here I have this species. It will have a formal positive here, because notice that now oxygen has 3 bonds. And now I'm going to say that the first step, this reaction that I just drew, is a nucleophilic attack, because again, your electron-rich species is attacking on a carbon. So an atom that's different to proton, which is what we see in proton transfer reaction. Proton transfer, remember, are basically bronzolurate acid-based reactions. So easy to recognize that way. So a species that acts as a proton donor and the other as proton acceptor. Now we have this reaction here, nucleophilic attack. We have this species. This is an intermediate, and we can also have, after this step, we can have a proton transfer step if we have, for example, another water molecule doing this. If we have that happening, that's an example of a proton transfer reaction. Again, electron-rich species, here are the electrons are attacking on a proton. And now you will have this here. I'm keeping that negative, and now I have OH. This reaction can continue, and we can have now this movement with loss of leaving groups. So notice that minus chloride is that's one way we rewrite that a lot. So minus this species, and this is your leaving group. And now you're forming your final product being a carboxylic acid, acetic acid. So what have we done? A mechanism that contains several steps, but notice the difference here. Nucleophilic attack is, again, your electron-rich species attacking on an atom that's not a proton. Here is an sp2 carbon. In this particular case, a nucleophilic attack, you have this intermediate species, and now notice an electron-rich species has lone pairs attacking on a proton. So that's a proton transfer step. And now we have one step that we call loss of leaving group. So we're going to give more examples of that. And that's important to recognize them, nucleophiles and bases.